Nintendo Switch. As always, the first thing you want to check on the Nintendo Switch is the port. There's been some structural damage. Top shield has been separated. I don't think I want to risk putting power to it, so let's go ahead and take this apart. This video is brought to you by PCB. More about their awesome services in a bit. We have the board removed from the housing, and we're preparing to remove our port. While I'm setting up my equipment, let me throw up my expected temperatures for this job. These temperatures are brought to you by the Amazon associate links in the description. If you head to my video description and click on one of these links and buy any of this equipment, or if you buy anything during that session, a small portion of that purchase will go to supporting the channel. And I greatly appreciate you. It won't cost you an extra dime. We will begin this task by flooding these anchor points with low melt. Now we'll slowly heat up the area. First thing we want to do is make sure we wet all these anchors. And then we'll start concentrating in on the pins. And when the pins are ready to release, the port will fall. Just like so. Nice clean pull. First thing we want to do is check the pads and make sure that none of them are bridged together. This would interfere with our readings. None of them look like they're bridged. Now we'll begin testing for any secondary issues, and you can post down in the comment below if you believe there's going to be any. And we'll begin our testing on this capacitor right here, which is tied to the Pi 3 USB on the back through the M92T36, and the side we do not want shorted to ground is the line going to the chip, and it is shorted to ground. So we definitely have a Pi 3 USB issue. Let's continue checking around the chip, and we have another short capacitor, which means we also have an M92T36 issue. What other issues will we have here today? Let's check this CPU capacitor and see if this is even going to be worth continuing with. Very good, at least that one's not short. A host of other problems, but at least that one's not short. Let's check our MOSFET area, and nothing shorted there. We'll check our invincible fuse, which clearly did not do its job. And now we're going to check our test pads. None of these test pads in this area should have a pathway to ground. And one does there. Now we're going to move over to the BQ24193 area. First thing we're going to test is make sure we don't have a short on this coil. We do not. We do want continuity through it. We do. Now we're going to check these two test pads. None of them should be shorted to ground. They are not. Now we'll check the caps around the BQ24193. We want to check the lines going to the chip. On this particular chip, there are multiple lines going from several capacitors. You just need to know which side to check. Only one side should be ground. And it looks okay there. And we already know from our testing on the other side that we have a problem with the Pi 3 USB. Right there. This line going to the chip should not be shorted to ground, and it is. These filters should have continuity going straight through, but not side to side. Alright, they do not, and none of them should be shorted to ground. Very good. So, we have a host of problem. Not only did we have a port issue, we have a Pi 3 USB issue and an M92T36 issue. I think our process here will be to pull and test, just to be sure. Let's check and see if our short has been removed. And it has. That's a good thing. We'll put a new one on. And check again. Here we are waiting for the center pad to wet. So we need to grab the chip. Do not let go of the chip until you're sure that it has grabbed. Remove the air, let it tack down. Then apply some downward pressure, not too much. Re-wet and push it flat. Clean up your mess. Test again. No short. Excellent. Check your alignment. Same routine with the M92T36. We'll pull it, we'll check and make sure our shorts are relieved, and if they are, we'll put another one on. Check and make sure our shorts are relieved. No shorts. We want the center pad to wet. Center pad is wetted. Now you want it to grab on before you let go of the chip. Center up. Remove your heat. Let it tight down. Put a little bit of downward pressure on it. Reflow and flatten to the board. Check again. No shorts have reappeared. In the cleanup process, we'll be greatly assisted by the low melt we applied earlier. From looking like a simple broken port to everything being wrong. A little bit of port damage can go a long way. Now for this, we're going to put a ball of solder on our tip, and we're just going to run that ball over these pads, like so. Same deal on the port. Ball of solder on your tip, and just run the ball over your pins. Sexy. Press down, remove the hot air, hold it down until you see evidence of drying. Take a quick gander of our outer pins. Make sure everybody's solid. Sometimes when you're concentrating on the inner row, you can neglect these guys, but everything looks good. Place a ball of solder on our tip, get the flow started. Excellent. Did you know our friends at PCB offer CNC and 3D printing services? Services like CNC machining parts online sheet metal fabrication, 3D printing, and online injection molding service. They offer many CNC machining materials, 3D printing materials, sheet metal materials, injection molding materials, and vacuum casting materials. Head over to PCBway.com and check them out today. We're ready to begin some power testing. We'll begin with our PSU dongle. This is a USB-C to 3.5mm adapter that we have hooked up to our benchtop PSU. What I want to see here is a quick jump in amperage and back down with no hanging. Like so. We want to see that on both sides ideally. Excellent. Now on PSU channel 2, using the modified iPhone Power Squid, which we have retrofitted with Nintendo Switch battery connectors. We want to see the Nintendo Switch boot up, which will just be a steady increase in amperage without hanging up. We'll activate with the OEM. Just a quick in and out. So far so good. We would like to see docking. Try the other side. There it is, yay! I hope this video is being helpful to you in your repair journey. Just a reminder, if this is something beyond what you want to try yourself, I do offer these services. Just head over to micromage.repair, click free quote, fill out the form, and I'll get back to you personally. We're back up on its battery, and we are fast charging at 15 volt. And we want to try with my Joy-Cons and make sure everything is connecting. A connection problem. Connector is badly corroded, so I'm going to clean that up, and we will try again momentarily. I cleaned it up a bit, and see if it connects now. And it does. Excellent. We're getting our networks, and we're getting Bluetooth. Excellent. If you enjoyed this video, I think you'll enjoy this one right here, and I'll see you there.